We're going to evaluate the integral of natural log of x plus square root of x. First thing we're going to do is make a substitution. Let y be square root of x. Squaring both sides, y squared then is equal to x, and differentiating dx is equal to 2y dy. Let's rewrite this integral then in variable y. It is the integral of natural log of y squared plus y times 2y dy. And here we're going to use the technique of integration called integration by parts. Let's review that. When the original integral, we can express it as the integral of u dv. It is equal to u times v minus the integral of v du. The idea is that hopefully the integral on the right is easier than the integral on the left. So we have to decide what is u and what is dv. Whenever natural log is involved in an integral and we're using integration by parts, most of the time letting u be the natural log part will work. So we're going to let u equal to natural log of y squared plus y and dv be 2y dy. Let's complete this by finding du and by finding v. So differentiating natural log of y squared plus y gives us du equals, in the denominator we have y squared plus y, in the numerator we have 2y plus 1 dy, and going from dv to v we have v equal to y squared. Now we can add any constant or subtract anything that we want if that will help us. In this case, letting v be y squared is okay. So now let's rewrite the original integral. The original integral was the integral of natural log of y squared plus y times 2y dy, and this is our u dv integral. It's equal to u times v, so that's y squared times natural log of y squared plus y, minus the integral of v du, which is multiplying y squared by 2y plus 1 over y squared plus y gives us 2y cubed plus y squared divided by y squared plus y dy. So now the problem comes down to evaluating this so-called integral. Notice this integral does not have a natural log. First, we know we can divide numerator and denominator by y, and it gives us the integral of 2y squared plus y, and in the denominator we have y plus 1. So how to evaluate this integral? We have a polynomial of degree 2 in the numerator and a polynomial of degree 1 in the denominator. One way we can do it is to perform long division by taking 2y squared plus y and dividing it by y plus 1. Let's do that. So first we get 2y. This gives us 2y squared plus 2y, and now we subtract. And we subtract 2y squared minus 2y squared at 0. Y minus 2y would be minus y, so we need a minus 1, and that gives us minus y minus 1. Again, we subtract. Minus y minus a minus y is 0, and then 0 minus a minus 1 is 1. So we stop right there. 1 is the remainder, and therefore 2y squared plus y divided by y plus 1 can be written as 2y minus 1 plus the remainder 1 divided by y plus 1. And so the integral then, the integral that we wanted to evaluate, the integral of 2y squared plus y divided by y plus 1 dy, can now be expressed as the integral of 2y minus 1 plus 1 divided by y plus 1 dy, which is a lot easier to evaluate. Let's go ahead and evaluate this integral. It's equal to y squared minus y plus natural log of y plus 1. I did not put absolute values because y was equal to square root of x, which is always positive at worst at 0, so there's no chance of having a negative value inside the natural log. So now let's return to the problem. We wanted to evaluate the integral of natural log of y squared plus y times 2y dy, and we wrote it using integration by parts as y squared times the natural log of y squared plus y minus the integral of 2y squared plus y divided by y plus 1 dy. Now we evaluated this integral, so this is equal to y squared times natural log of y squared plus y, and then minus the integral we just evaluated, which is in parentheses y squared minus y plus natural log of y plus 1, and we can add a constant here, c. And one more thing is the original integral was in variable x, so let's express this in variable x. The original integral was natural log of x plus square root of x dx, and it is equal to y squared, which is x, times natural log of y squared, that's x, plus y, which is square root of x. Then we have minus y squared, so that's minus x, plus y, that's plus square root of x, and minus natural log of y plus 1, so that's natural log of minus natural log of square root of x plus 1, and then we added a c at the end. For more